Greetings everyone. I am Uday Sharma from the Triple Department of Institute of Aeronautical Engineering. Today, I am going to discuss about the topic General Aviation Safety. Flying with paper maps, flying with digital maps. Aviation is often seen as an innovative sector eager to seek technological solutions. It is often assumed that aircraft cockpits have panels with electronic displays and many buttons. General aviation is defined as civilian flights that are non-commercial. General aviation comprises 90% of the world's civilian aircraft. Non-commercial civil aircraft, known as general aviation (GA), typically have cockpits that mainly consist of analog instruments that show how the heading of the aircraft, the altitude, and airspeed. While such conventional cockpit designs might seem the norm in general aviation, emerging technologies such as space-based technologies, global positioning systems or GPS, and portable computers, commonly known as tablets, are increasingly making their appearance in general aviation. Despite the widespread use of space-based and portable technologies and their potential benefits, surprisingly, they are not part of the official training for pilots. Some of these methods are not certified by the regulated aviation authorities. The main emerging technologies in general aviation are presented. The safety implementations and discussed of using such emerging technologies by pilots who were trained on conventional paper maps, compasses, rulers, and pens. To the diversity of the sector, let's discuss about the private and recreational flights using fixed-wing single-engine aircraft, including microlight, ultralight, rotorcraft, or glider. Mostly in other parts of the world, the GA fleet primarily focuses on the fixed-wing aircraft and helicopters. As simple regulation of general aviation, these reduce the cost of maintenance and training. General aviation pilots could be described as occasional flyers, pilots that fly as little as 30 hours per year, as these typically fly in good weather conditions and have relatively fewer flying hours compared to the commercial aviation pilots. For a flight to safely reach its destination, the details of the flight route are planned ahead to navigate along the route and estimate fuel consumption. In flight planning, pilots are meant to select distinctive landmarks across the route, estimate arrival times, and make corrections of the heading and altitudes based on forecasted weather reports. If it is the first flight to the plane destination, general aviation pilots are trying to use paper charts, compasses, protractors, calculators to complete flight plan sheet. Using these resources, once pilots are up in the air, the pilot monitors their aircraft position by observing the analog instruments of airspeed and heading, the distance and the time traveled, the selective landmarks. In the 2000s, the use of global positioning systems, GPS receivers, marked the beginning of space-based navigation for general aviation. The evolution of portable computers and software development led to the emergence of flight planning software applications in tablets that string all the information printed on a paper into a small multifunctional device, a tablet with a touch display. When connected to the internet, the software applications can project the position of the aircraft in a moving map using GNSS receiver installed to the tablet. Enduring challenges. Changes in flight planning and navigation can cause safety issues that originate from failures of assistive technologies depending on the manner in which technologies are used. Failures of such space-based navigation devices and software applications can originate from a variety of sources: a weak internet connection, a weak satellite signal, and a technical failure of the tablet's components, programs, and the software application itself. The tablet can run out of battery power, ongoing challenge for electric devices. Given that the general aviation pilots can often fly more than an hour, the devices can run out of battery during the return flight to their home airfield or during cross-country flights. And thus pilots need to plan ahead and consider using alternative resources. General aviation population is aging. The age of general aviation pilots range from 18 to 90 years of age in United Kingdom and Canada. As physical and cognitive performance naturally degrades with age, touchscreens and software applications require actions that an older individual might find too demanding. Satellite tablets and software applications can be described as relatively recent technologies developments. Do GA pilots know how to use satellite operates? Do they understand how a tablet can turn off at any time the internet connection will be lost when in flight? These concerns not only arise for older GA pilots, but for younger pilots as well. Pilots relying on GNSS could find themselves flying in conditions beyond their capabilities. Traditionally, paper aeronautical charts are placed flat on the knees of the pilots, along with all the other documents the pilots carry on board. From discussions with pilots, one tablet is often placed on the knee, probably as the natural reaction to the replacement of paper charts, or it's mounted on the top of the cockpit panel. Understanding the scale of the map is again another issue of the features presented change perspective as the user zooms in and out. In a static manner, the presentation of icons affects the engagement of the user with the device. It does not show nearby traffic, nor does it make decisions for the pilot. Pilots search for information, examples, weather information, and look out the window to become aware of traffic. As GNSS performance cannot be yet completely precise and accurate to required level for such a safety critical activity, pilots still need to navigate visually. When a GNSS was available, indicated that pilots could rely on the GNSS and find themselves flying in conditions beyond their capabilities, including navigating adverse weather conditions. In flight, relying as a technology that produces inaccurate results can result in unsafe situations. The most severe example being a mid-air collision in busy airspaces such as those in Europe over major cities. Traffic density can be high, meaning that pilots need to maintain the awareness of nearby aircraft. General aviation aircraft can be equipped with a traffic collision avoidance system, known as TCAS, in commercial aviation, and thus the eyes of the GA pilots remain the only traffic awareness systems on board. Hence, a tablet that is stayed for a long time can degrade pilots' traffic awareness. Increase the likelihood of an event when the pilot does not see the nearby air traffic and the plan accordingly. In light of the technologies that present the air traffic information as mentioned earlier, more information is centralized in the electronic display, highlighting the issues of changes in planning and navigation for the pilots. General aviation is indeed in a transitional phase with emerging technologies making their appearance in the cockpit primarily in the form of satellite-based technologies and emerging technologies introduced to general aviation should be verified for their operational and safety benefits. Software applications installed on portable electronic displays, emerging technologies, and embedded into the operations of such a safety critical industry without training and with some technologies. Such assessment will not only improve the design of the technologies, but it will also inform policymakers with respect to actions needed to ensure the safe use of these technologies, including training schemes, minimum performance and requirements, and standards. Thank you. This is UDAY SHARMA signing off.